Hi everyone. So in the previous video we saw the EM wave analysis in a general direction. Our wave was traveling in a general direction. It was not traveling into plus x minus x or plus z minus z or plus y minus y. It was traveling into xy, yz or zx. In that manner it was going. So if you are someone who is watching this video only for oblique incidence part, if you are someone who only needs the oblique incidence part, then I highly recommend to watch the previous video which was posted yesterday. So that previous video of 110 minutes that you need to watch. Otherwise, you will not be able to understand anything in oblique incidence. So that video is the prerequisite of oblique incidence. So I highly recommend to watch that particular video. Then come to this topic. Okay, so we have already studied normal incidence. In normal incidence, what was happening? This was our boundary plane. A wave was coming. It was striking like this, and it was being reflected, and some part was transmitted. So wave was striking normally. It was striking normally like this. Now wave would be striking like this. It would be coming at an angle, and then it will be reflected like this, and some part will be transmitted. So the wave is coming like this. This is the wave. Wave is coming like this. This is the electric field. This is the magnetic field. Now wave is coming like this. Now it will be, some part will be reflected, some part will be reflected, and some part will be transmitted. Let's just say here it is striking. So now some part will be transmitted. Some part will be transmitted at a different angle. It will be transmitted. It could be transmitted at the same angle as well. It could be transmitted as different angle as well. So some part will be transmitted. And now this is the perpendicular unit vector. Okay. If this is z equals to 0 plane, so this would be plus minus az. This line is plus minus az cap. Why it is plus minus az? Because perpendicular of z equals to 0 is plus minus az cap only. This we have already seen in simple vector algebra as well. Okay. Yeah. So this was our incident angle, and this is our reflected angle, and this is our transmitted angle. Okay. So let's make it more clearly. So this is our boundary plane. This is known as boundary plane. This is boundary plane. So I am drawing from downward. Okay, I am drawing from downward. This is my incident wave now. Okay, this is my incident. This is my reflected, and this is my transmitted. Okay, this is the theta I angle, incident angle. This is your reflected angle, and this is the transmitted angle. Is that clear to you? Well and good. Okay. Now there is one thing. What is that? That this is my incident wave, this is my reflected wave, and this is my transmitted wave. Now all these three waves will be lying on a certain plane. What I am saying, this incident wave, reflected wave, and transmitted wave, all these three waves will be lying on one plane only, and that plane is known as plane of incidence. Incident wave, reflected wave, and transmitted wave will be lying on one plane only, and that plane is known as plane of incidence, and that plane of incidence is perpendicular to the boundary plane. Incident, reflected, and transmitted wave lie on the same plane. Like from these all these three waves will be lying on the same plane, and this plane is known as, what it is known as, plane of incidence, and it is perpendicular to the boundary plane. Is that clear to you? Okay. Incident, reflected, transmitted, all will be lying on one plane only, and that will be perpendicular to the boundary plane. Okay. This is my boundary plane, and somewhere in between my plane of incidence would be there, and that will be perpendicular to the boundary plane. A very important concept. Okay. So that we are going to write down, plane of incidence. So incident wave, reflected wave, and transmitted wave will lie on the same plane, and this plane is perpendicular to the boundary plane, and this plane is known as plane of incidence. So this is my plane of incidence. And this is your boundary plane. This is incident angle, this is your reflected angle, and this is your transmitted angle. This I am calling my incident wave, this I am calling as reflected wave, and this I am calling as transmitted wave. All are lying on the same plane, and this angle is 90 degree. Okay, again showing this angle is 90 degree. So from now onwards, whenever I do the analysis, I will only make plane of incidence. I will only make plane of incidence, then I would know that my boundary plane is perpendicular. I would know that my boundary plane is perpendicular. So for analysis purpose, I will always make a plane of incidence. Let's just say I get to know that my plane of incidence is xy plane. So I will only make x axis and y axis, that's it. then I would know that my z axis would be, let's call this as x, this as y. So I will make x axis and y axis, then I would know that my z axis will be coming towards me. So for analysis, we will always make plane of incidence, because in the plane of incidence you will have incident wave as well, reflected wave as well, and transmitted wave as well. So I can make incident wave, reflected wave, and transmitted wave on plane of incidence only. Then I would, in my mind, I would know that my boundary plane is perpendicular. It could be like this as well, it could be like this as well. If this is my plane of incidence, if this is my plane of incidence, this is my plane of incidence, then my boundary plane could be like this as well, like going like this, or it could be going like this as well, right? It could be going like this as well. From towards this plane, from this plane, there could be two perpendicular plane, this plane or this plane, right? Two perpendicular plane would be there. So that will be mentioned, that which is your boundary plane. Boundary plane will be mentioned in the problem itself. Even the plane of incidence will also be mentioned in the problem itself. We just need to understand which is our boundary plane and which is our plane of incidence. So that we need to understand by looking at the problem. So those problems we are going to see. There you will understand that how to determine whether it is a boundary plane or plane of incidence. But for now, what you will remember, that for analysis purpose, we will always make plane of incidence, and then we would know that boundary plane is perpendicular. So there is no issue about that. Okay. Now there are two kind of polarization defined. With respect to oblique incidence, there are two kind of polarization defined, that is known as parallel polarization and perpendicular polarization. So for now, you forget the name. You forget the name parallel polarization, perpendicular polarization. You just let me know what is this plane. Which plane is that? Whether it is a plane of incidence or boundary plane. It is a plane of incidence, because I told you in plane of incidence you will have incident wave as well, you will have reflected wave as well, and you will have transmitted wave as well. So in this plane only you can see I have made incident wave, reflected wave, and transmitted wave. So this is my plane of incidence. Plane of incidence. Same goes here. Plane of incidence. And this is your boundary plane. Although I have made it like this as well, like although I have made it like this, that you would get, you are seeing it that this is a 3D plane, but I could have made it like this as well. How? Like this, that I wouldn't even make this guy. Okay. So you need to understand that this is my boundary plane. How did you understand this is my boundary plane? Why did not you say that this could be also your boundary plane? What I am saying is that why this is your boundary plane, why this is not your boundary plane? Try thinking about it. Look, if I say this is my boundary plane, if I say this is my boundary plane, what I am saying, this is my boundary plane. If I say this is my boundary plane, then what would have happened? That incident wave would come and then it would be reflected in this direction, right? Incident wave would come and it would be reflected in this direction if this was my boundary plane. So this wave would have come and would have been reflected in this direction. But what is happening? The wave is being reflected in the other direction. That means this has to be the plane of boundary, right? This has to be the boundary plane, because wave came and then reflected, came and reflected. So this has to be the boundary plane. So this is my boundary plane. Which is my boundary plane? This is my boundary plane. Okay. So this is incident wave, reflected wave, and transmitted wave. Is that clear to you? All these things are clear. Now what do you mean by parallel polarization? So in parallel polarization, listen to me very carefully. In parallel polarization, electric field is tangential or parallel to plane of incidence. In parallel polarization, electric field is tangential or parallel to plane of incidence. Now this is my wave of propagation, right? My wave is propagating in this direction. So where can be my electric field? My electric field can be, let me use this pen or this pen. My electric field can be here, or it can be here, or it can be coming towards you, or it can be going into the plane. There could be 4 directions possible. Again I am telling, if this is my wave propagation, if my wave is propagating like this, then my electric field has to be perpendicular to the wave of propagation, right? Electric field is perpendicular to the wave of propagation. So it could be here, or it could be here, or it could be coming towards you, or it could be going into the plane. There are 4 perpendicular directions. Like if this is my line, then one perpendicular would be like this, here only. One perpendicular could be like this, one perpendicular could be like this, other perpendicular could be like this, one perpendicular could be coming into the plane, like it is coming towards you, and one perpendicular could be coming towards me here. Okay, so 4 perpendicular are possible. Now what does parallel polarization say? That it has to be tangential to the plane of incidence. That means there are only 2 possible chances, either this or this. Electric field has to be tangential to the plane of incidence. Now this is my plane of incidence, here is my incident wave, this is my plane of incidence, this is my incident wave. So what is the chances of electric field? This could be electric field, this could be electric field, or this could be electric field, or inside it could be the electric field. But in case of parallel polarization, the electric field has to be perpendicular only. Sorry, it should be in the plane of incidence only. So it could be this as well, or it could be this as well. So I am assuming that this is my electric field. This is my assumption. This is also possible, but my assumption is, just to show in the diagram, I am assuming that this is my electric field. Is that clear to you? So you have the direction of electric field, you have the direction of propagation. Where will be your magnetic field? What will be the direction of magnetic field? You should be able to tell. E cross S should give me P, so it should be coming towards you. So this should be the direction of magnetic field. And if I had made otherwise, like if I had made that this is my electric field, then magnetic field would be going inside, right? Magnetic field will be going inside. So that depends on the direction that you have made. There are only 2 possible direction of the electric field, either this one or this one, either this side or this side. So we are making on this side. If we are making on that side, that means what will be the direction of magnetic field? How will you get the direction of magnetic field? Because I know that P is equals to E cross H. So E cross H should give me P. So my thumb should be directing towards P. So E is on this direction. This is my P. This is my E. This is my P. So cross H should be coming towards you. E cross H should give me P. So this you should be comfortable, because we have seen the last lecture, E cross H should be P. Or you can determine from here as well that H is equals to P cross H. So H is equals to P cross E. H is equals to P cross E. So P cross E coming towards you only. Now this is your reflected wave, right? This is your reflected wave. Let me use this color pen. Now this is the reflected wave. Here also there will be electric field and magnetic field. So what are the possible direction of electric field? What did I say? In case of parallel polarization, electric field has to be in the plane of incidence only. In case of parallel polarization, electric field has to be in the plane of incidence. So where can you have your electric field? Here or here. Electric field has to be perpendicular to the direction of propagation. So this direction is possible, other direction possible is this. Although there are 2 more possible direction, this one or this one, but we will not take them in action. Why is that so? Because we are studying parallel polarization. So in case of parallel polarization, there are 2 possible direction. Which are those? This one and this one. But I will take this one in action. Okay. For analysis purpose, we are taking this one in action. Like we will derive the formula for a certain condition, then we will get a value of gamma. And if gamma is coming negative, that means the assumption that we made, that is opposite of that. The same way that we studied normal incidence, in the same manner we are going to derive. So one assumption we need to make from our side, that this is how my electric field is going. Okay. So this is how my electric field is going. This is my reflected electric field. This is the assumption I am making. How to remember the assumption, that which assumption we have made, that also I will tell. But it is not important to remember. Okay. But I will also tell that how to remember the assumption that we are making to derive the expression. So this is the reflected wave. So what should be the direction of a magnetic field? You think on your own. E cross H should give me P. So P should be towards a thumb. E is this, E cross H. That means H is inside. So that should be the direction of magnetic field. E cross H should give me P. Incident and transmitted will have the same direction only. If you remember in normal incidence as well, basically this is my wave was coming, this is my incident wave, and this would be my transmitted wave. So they will have the same direction of electric field and magnetic field. So this direction will not change. They will have the same direction only. This is your transmitted electric field. Look, angle, like this is my theta E, okay, and this is my theta T. So theta T angle would be changing. That means actually this direction, you cannot say that, sir, API is equals to APT. This you cannot say. because the deviation has changed, no? The wave, this wave was coming at theta angle. Now it will be striking at this plane of incidence and going out by different angle. This theta t and theta I is not different. Is this theta I and theta t is not equal. So certainly this direction would change. But I am talking about the orientation. That electric field will be in this direction only. Although this direction and this direction is not same in this case, but will be pointing towards this direction only. If this incident wave is pointing towards here, if this incident electric field is pointing here, then my reflected electric field will be pointing there only. So that orientation will be same. Is that clear? So this is my transmitted electric field, not reflected, sorry, this is my transmitted electric field, and this is my transmitted magnetic field. Okay. So let me make it more clear. So this was our parallel polarization. I hope you must have understood. In parallel polarization, E is parallel to the plane of incidence. So here I am writing E is parallel to the plane of incidence. Here perpendicular polarization. So in perpendicular polarization, E will be perpendicular to the plane of incidence. It will be perpendicular to plane of incidence. So E will be perpendicular. So E could be coming towards me or going into. So I am assuming E is coming towards me. Okay. So what will be the direction of H? So direction of H I need to determine. So how would you determine? So direction of H I can determine from P cross E. So this is P cross E. So H would be going downward. H would be going downward. H would be going downward. All these are incident. This is HI. This is PI. This is theta I, theta R. Okay. This is your PR. Now again electric field here. The reflected electric field can have also two direction, either coming towards you or going into. So I am assuming that this is coming towards me only. So my assumption is that this electric field is also coming towards me only, reflected electric field. You are not sure whether it would be coming towards you or it will be going inside, that you do not know. But now your assumption is that it is coming towards you only. So if this is coming towards me, then what would be the direction of magnetic field? How would I determine P cross E? So P cross E. So this will be the direction of magnetic field. This will be the direction of magnetic field. So this is the direction of reflected magnetic field. And orientation will be same only. So this will be your direction of transmitted electric field, and this will be the direction of transmitted magnetic field. So now all these terms should be clear to you. What do you mean by parallel polarization and what do you mean by perpendicular polarization? I hope these things are clear to you. What I am saying, that in case of parallel polarization, electric field will be parallel to the plane of incidence, and in case of perpendicular polarization, electric field will be perpendicular to the plane of incidence. Now in the other way, what I can say, that in case of parallel polarization, magnetic field will be perpendicular to the plane of incidence. Is that clear to you? In case of parallel polarization, magnetic field will be perpendicular to the plane of incidence, and in case of perpendicular polarization, magnetic field will be parallel to the plane of incidence. Is that clear to you? I can say otherwise as well. I will remember for electric field only. One thing I will tell you, that whenever polarization word comes, whenever polarization word is coming, polarization, whenever this word comes, you always need to think about E field. Polarization is always defined with respect to electric field only. It is not defined with respect to magnetic field. Okay. But they can frame a question like this, that in case of parallel polarization, E field is parallel to the plane of incidence. Yes. But in case of parallel polarization, H field is perpendicular to the plane of incidence. Yes. This was our parallel polarization. E field is tangential, but H field is perpendicular as well. Because if E is tangential, then certainly H has to be perpendicular only. No, there is no other way. So H is perpendicular, and in the same manner, in perpendicular polarization, E field is perpendicular to the plane of incidence. Yes, in perpendicular polarization, E field is perpendicular to the plane of incidence. But in perpendicular polarization, H field is tangential or parallel to the plane of incidence. Yes, H field is tangential or parallel to the plane of incidence. So all four are correct. Is that clear to you? Are you able to visualize what I am saying. So whenever polarization word is coming, so let's just say in the examination it is written parallel polarization. So how would you think? Okay sir, parallel polarization. Polarization means I need to think about electric field. Now they are saying parallel. That means E field will be parallel to the plane of incidence. That's it. Is that clear to you? All good? Yes? Okay. So this is a very important point which aspirants do not understand much. They directly jump on into studying oblique incidence, but here we are building a very good prerequisite of our oblique incidence, right? Now let's solve some questions. So EM wave E field expression is given as this: determine the plane of incidence and all possible boundary plane. Is it a perpendicular polarization or parallel polarization? So these kind of questions will not come in your examination. This is just to build your concept, okay? Just to build your concept, these problems I am framing. So they will not come into examination, and they are neither taken from any textbook. Like this is not from Sadiq or anywhere. You will never find it in textbook. These questions just I framed just for building up your concept. Before jumping into the concept, we need to build up the concept as well, right? If we directly jump into the concept, then there is no use of that. Why I am teaching then? You could have read the textbook as well, no? So that is our job, that first we need to understand the concept. So that's why we are studying it. So we need to determine the plane of incidence. So what did you see here? In the plane of incidence, EM wave will be there. Deflected EM wave will be there and transmitted EM wave will be there. But one thing is for sure, that the direction of EM wave, the direction of incident EM wave will be certainly lying on the plane of incidence. Is that clear to you what I am saying? The direction of EM wave will be certainly lying on the plane of incidence. So what is the direction of EM wave in this question? Can you write down the K vector directly? Yes. Minus sign I will take outward. 3ax cap plus 4ay cap. So what is my direction of propagation? What is my direction of propagation? That is 3ax cap plus 4ay cap divided by 5. That means my direction of propagation is in xy plane. Is that clear to you? I am working 3 in x, 4 in y. Then that means certainly it is in xy plane only. Is that clear to you? If I make it like this, that this is my x and this is my y. So I am working 3 in x and 4 in y. So this will be my plane of incidence. This will be my plane of incidence. Sorry, this is my incident EM wave. Now incident EM wave will be lying on the plane of incidence only, no? My incident EM wave will be lying on the plane of incidence. So certainly this is my plane of incidence only. XY plane is the plane of incidence. So where your wave is lying, where your incident wave is lying, that is your plane of incidence. Now what will be your boundary plane? Boundary planes. You let me know one thing. This is x, this is y. Where will be z? X cross y should give me z. So this will be my z, right? Now what all possible boundary planes are there? Boundary plane and plane of incidence. Boundary plane and plane of incidence both are perpendicular to each other, right? Boundary plane and plane of incidence both are perpendicular to each other. So xy plane is the plane of incidence. Then boundary plane could be yz plane or xz plane. Say yes or no, right? Boundary plane could be yz plane or xz plane. Okay, what is the equation of this plane yz plane? That is x equals to 0. And what is the equation of xz plane? That is y equals to 0. So all these basic things you should know. If we are going into xz plane, that means certainly your y is equals to 0. And if you are going into yz plane, that means certainly x is equals to 0. And from here also you can understand that my wave is incident like this. So either this could be my boundary plane or this could be my boundary plane. My wave is incident like this. So this could be my boundary plane, this hand, or this could be my boundary plane. So this is my boundary plane. If this is my boundary plane, then what is the equation of this plane? X is equals to 0. Are you getting this point? Are you getting this point? If yz is my boundary plane, if this is my boundary plane, then my equation would be x equals to 0. And if this is my boundary plane, that means this is xz plane. Xz plane. If this is my boundary plane, you see in the direction xz plane. So what is the equation of xz plane? Y is equals to 0. So in the question itself, one of the plane will be mentioned. In the problem itself, it will be mentioned. Like this is not the problem of oblique incidence. This is just a conceptual problem which we are framing to understand the concept. So, but these things will be mentioned in the problem itself, that which is your boundary plane. Okay. They will also mention the incident electric field as well. okay, or incident EM wave as well. So you will get to know the plane of incidence as well. From there you can get to know the boundary plane as well. So both planes you will be getting to know, and then you will be able to solve the problem. So that is the most primary task, to determine the plane of incidence and the boundary plane. So now you let me know whether it is a perpendicular polarization or parallel polarization. So how would you think? That, sir, this is my EM wave. Where is my electric field? My electric field is in Z direction. So this is my electric field. This is my electric field, right? So my electric field is perpendicular to plane of incidence. Plane of incidence. So which kind of polarization is that? Perpendicular polarization. Okay, this is perpendicular polarization because electric field is perpendicular, right? Now one more thing I wanted to tell, this perpendicular polarization is known as S polarization as well. S polarization. And this parallel polarization is known as P polarization. P polarization. How will you remember these words P and S? You can remember by any trick, but how I remember? In parallel polarization, how many P's are there? 1 and 2. In P polarization, how many P are there? 1 and 2. So that's why parallel polarization is equivalent to P polarization. Now you will say that in perpendicular polarization as well there are 2P. 1P and 2P. No, there are 3P, no. So if there are 3P, that means it is not P polarization. If there are 2P, here also there are 2P, here also there are 2P. That's why it is P polarization, other one would be S polarization. So this is how I remember. Okay. Parallel polarization, PP. P polarization, PP. Here perpendicular polarization, 3P are there, so that is S polarization. So this is how you can remember. In the examination, this name can also be written sometimes. A very rare chance, but this name can also be used in the examination. So that's why you need to remember. This is P polarization, this is S polarization. Is that clear to you? Yes. Okay, let it be so that you remember actually. P, 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 P. P, 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 that means S. Okay. Yeah. Solve this question on your own. I will take a pause. Okay, drink some water. I will take a pause. Then you solve it. You will be able to solve this question. Like in 27 minutes, if you have studied something, then certainly you will be able to solve this problem. Okay. So I will take a pause. Yeah, so let's see this question. So in this question, what is the direction of wave propagation? It is same as the previous question. Ditto same example is there, just this guy has changed. Previously it was AZ gap, now it is minus 4AX plus 3AZ gap. So what is the direction of wave propagation? 3AX gap plus 4AZ gap divided by 5. So which plane I will make? I will plane XZ plane, right? XZ plane is my plane of incidence because my wave is propagating in XZ direction. So my XZ plane is the plane of incidence. This is my plane of incidence. Okay, so what could be my boundary plane? Boundary plane could be XY or YZ, right? The equation of XY would be Z equals to 0 and equation of YZ would be, what would be the equation of YZ? YZ would be X equals to 0. How will I make the diagram? XZ plane, XZ. So here I am making X, here I am making Z, XZ plane. So this is how my wave is going. 3 in X and 4 in Z. 3 in X, basically 3 in X and 4 in Z. So this is how your wave would be going, right? Now, where is minus 4AX plus 3AZ? Minus 4AX plus 3AZ. That means 4 in minus X and 3 in Z. 3 in Z. That means this is the direction of electric field. So this is the direction of electric field. Basically, electric field has to be perpendicular to the direction of propagation. Now I need to know whether it would be in this direction, or it would be in this direction, or it would be coming towards me, or it would be going into plane. So one of the direction is possible. Out of 4 direction, one of the direction is possible. Now what they are saying? Minus 4 in X and plus 3 in Z. So what is the direction of propagation? This is the direction of propagation. So at this point, this will be my electric field direction, right? So which kind of polarization is that? Which kind of polarization? Parallel polarization, because electric field is in the same plane, right? Electric field is in xz plane only. Electric field is in xz plane. Xz plane, which is your plane of incidence. Plane of incidence. So that's why it is parallel polarization. Previous example was the example of perpendicular polarization. This is parallel polarization. Can you show me the direction of magnetic field? Can you tell me what will be the direction of magnetic field? So what will be the direction of magnetic field? P cross E. Direction of magnetic field will be going inside. This will be the direction of magnetic field, because P cross E, yes, going inside. Is that clear to you? All these things are clear. So I hope you are able to visualize the electric field, magnetic field, and the direction of propagation, right? Now incident and reflected waves have been shown. You need to determine the boundary plane. Very easy question. Try doing it on your own. This is x, this is y, this is x, this is z. So where would have been y? X cross y should give me z. So this would be my y, right? This is my y. This is my y. Now wave is coming like this. Wave is coming like this, and it is reflected like this. Wave came like this, and it is reflected. So this has to be my boundary plane, right? This has to be my boundary plane. So this is my boundary plane. So my boundary plane is xy plane. Boundary plane, which is xy plane. That means z equals to 0. Now here wave is coming like this and reflected like this. Came like this and reflected like this. So that means this has to be boundary plane. Came like this, it came like this and reflected like this. Like this it came and then it got reflected. So this has to be the boundary plane. So what is my boundary plane? YZ plane. That means what is the equation of YZ plane? X equals to 0. So here x equals to 0 or z equals to 0 could be my boundary plane, but looking at the diagram I could get to know which is my boundary plane. Now can you tell me what will be your incident angle? Whether this will be my incident angle or this will be my incident angle. So in the last lecture I told you incident angle is always defined with respect to the perpendicular. So this is my plane, and what is perpendicular of that? This is the perpendicular. So this would be your plane, this would be your incident angle, and this would be your reflected angle. Here what would be my incident angle? This would be my incident angle or this would be my incident angle. So always defined with respect to the perpendicular. Now this is your boundary plane, this is your boundary plane. So perpendicular would be like this. This would be my perpendicular, right? This would be my perpendicular. This is my perpendicular. And this is my incident wave. So along the perpendicular it is defined. So this is my theta I. And this would be theta R. This is incident angle, reflected angle, incident angle, reflected angle. Is that clear to you? All thing is crystal clear, right? A wave is traveling in xz plane and it is incident on z equals to 0 plane. Show the reflected and transmitted wave. So you need to draw the diagram basically. You just need to draw the diagram that how incident wave would be coming, how reflected wave would be coming, which plane you will make. So which plane I will make? Xz plane I will make, xy plane I will make, or zy plane I will make. Which plane I am gonna make? So for that I need to see the direction of propagation. So this is the direction of propagation. So that means certainly I need to make xz plane. Xz plane. So I am gonna make xz plane. Now where will I keep x and where will I keep z? X here, z here, or x here, z here. So this I already told you in the last lecture. What did I say? That first I will see my boundary plane. What is my boundary plane? Z equals to 0. Now what will be the perpendicular vector? Perpendicular vector would be az cap. So I will always try to keep perpendicular vector on the horizontal direction. So this I will make z, this I will make x. Why I am doing so? Because x cross y will give me z. So this will be my y. If this is x, this is z, so this would be my y. Now this xy plane is my boundary plane. Basically z equals to 0 means xy plane only. Xy plane only. Z equals to 0 means xy plane only. Now how my wave is coming? Positive x and positive z. That means wave is coming like this. So wave is coming like this. You will slowly understand why I am doing so. The wave is coming like this. Now you let me know one thing. Where will be my reflected wave? Reflected wave will be here or it would be here. Where will be my reflected wave? My reflected wave will be here because my boundary plane is this. This is my boundary plane and this is my incident wave. So reflected wave will be here. And if I had made this as my boundary plane, then reflected wave would be here. Basically, if I had made this guy as x, if I had made this guy as x and this guy as z, then xy plane is my boundary plane. So this would be my boundary plane. Then this would be incident wave and this would be the reflected wave. So anything can be happening, like you can keep anything x z or z x, but what I usually do is that I will always try to make this as my boundary plane. So if this is z equals to 0, so I will try to make this as my boundary plane. So xy plane I will try to keep like this, or you can remember in that manner that first I will see the direction of propagation. That means I need to make x z. Now how to decide whether to keep z here or x here? So you just see this z equals to 0. So now what will be the perpendicular vector? Az gap. So I will always try to keep perpendicular vector horizontally. So I will try to keep perpendicular vector horizontally. So if I keep z here and x here, that means now this will be my boundary plane. So this is my incident wave. Where will be my reflected wave? This will be my reflected wave. So this is incident wave and this is my reflected wave. And what will be my incident angle? Incident angle is always defined with respect to perpendicular. And what is the perpendicular here? This is the perpendicular here. So it is always defined with respect to perpendicular. So this is your theta I. This is your theta r. I can show that transmitted wave as well. So let's show the transmitted wave. This is the transmitted wave. It could be at any angle. The angle could be less as well. The angle could be high as well. So that we are not commenting. Let's make the angle less. So this is your theta r. Okay. Regarding the electric field, they are not showing anything. So this diagram I wanted you to make. So first, what did we show? First we saw the simple like wave is traveling and which plane is the plane of incidence. Then we came to the boundary plane. Here we saw the perpendicular polarization and parallel polarization. Then we came to the boundary plane. Then we combined everything. So now we will get into our oblique incidence. Now you will feel very good. You are able to solve all the problem of oblique incidence. So in the previous video we spent 110 minutes. Now we have spent 40 minutes. Now we have built up all our concept for oblique incidence. Now we will go into oblique incidence part. And you will feel it very easy. And believe me, this is the toughest topic for the students who study EMFT. Because they directly start from here. Basically from here they will directly start. So if you directly start from here, then it would be tough only. But that 140 minutes or 150 minutes, that are very important for us. So I hope you must have felt very good and you must have understood all the points. Let's start our oblique incidence. But before that, let's understand wave optics. So have we studied wave optics? In our 10th, 11th classes, we have studied wave optics. So you do not need to remember wave optics completely. What I need you to tell that our theta I would be equals to theta r. Basically, this angle would be equals to this angle only. Okay. And let's just say this is my medium 1 and this is my medium 2. This is my medium 1 from where wave is coming and where the wave is transmitted. This is your medium 2. So theta I would be equals to theta r, and other thing would be equals, what would be the other thing? That beta 1, beta of medium 1 sin theta I would be equals to beta of medium 2 sin theta r. Sin theta t, sorry, not sin theta r. Oh, really sorry. Yeah, all fine. So this is how I need to, these two law I need to remember. That incident angle and reflected angle will be same. Then this, what this was known as? This was known as Snell's law. And what was Snell's law? Snell's law was saying that refractive index of medium 1 into sin theta I is equals to refractive index of medium 2 into sin theta t. Both are equal. This was known as Snell's law. Snell's law. This was your medium 1. This was your medium 2. It was having refractive index N1. It was having refractive index N2. This is not neta. This is not intrinsic impedance. Okay. This is your refractive index. But refractive index is not a property of wave. That's why refractive index will be replaced by beta. So you just need to remember this thing. Sin theta I is equals to sin theta t. And what do you know? What is your beta? Omega under root mu 1 epsilon and sin theta I is equals to omega under root mu 2 epsilon 2 sin theta t. This law you will be able to remember. Okay. And this law you should remember. Beta 1 sin theta I, beta 1 sin theta I is equals to beta 2 sin theta t. That's it. And we can break it out. Omega will always be same. What did I say? Omega never changes. So omega gets cancelled out. And if it is non-magnetic material, non-magnetic material, or non-magnetic material, what will happen? Mu 1 will be equals to mu 2 will be equals to mu naught, because mu r is 1. So this will also get cancelled. So what will be the answer? Root epsilon r1 sin theta I. because epsilon 1 is epsilon r1 epsilon naught. Basically epsilon 1 is equals to epsilon r1 epsilon naught, and epsilon 2 is equals to epsilon r2 epsilon naught. So epsilon naught gets cancelled. So epsilon r1 sin theta I is equals to epsilon r2 sin theta t. So in some textbook this also you can find. In some textbook this formula would be written, but this is coming after this condition, that if this is true then this formula would be true. So better remember this formula, right? Better remember these two formula only. So this you can derive there directly. So if non-magnetic material is mentioned, then you can directly apply this formula. But why should we remember it? We should remember this formula. So what you need to remember from wave optics, theta is equals to theta r, and beta 1 sin theta is equals to beta 2 sin theta. Where here refractive index you do not even need to remember. Don't even think about refractive index. What you are going to think? You are going to think about beta. So beta 1 sin theta is equals to beta 2 sin theta t. Now some people will be getting confused in the examination. In the longer run you will be getting confused that sir whether it will be sin or cos. Like you will be writing down the formula, sir beta 1 cos theta I. In that manner you will write down that beta 2 cos theta t. So that confusion you can have. How will you remember? Snell's law. Snell starts from S. S means sine. Okay. So always sine will come. In Snell's law sine comes. That's how I remember. Why you would be getting confusion theta? Why you would be getting confused between sin theta and cos theta? Because now we are going to derive our formula for gamma. We are going to derive our formula for reflection coefficient. We are going to derive our formula for reflection coefficient. So there cos theta will come. In that formula cos theta will come. So you will be getting confused, like sometimes I have seen the aspirant writing beta 1 cos theta I. So that error may happen. So how do you remember it? Snell's law. Snell as a sine, and in the in this reflection coefficient the formula will be regarding the cos. Okay. So we will derive the formula now. Let's start studying our perpendicular polarization. So in perpendicular polarization, electric field is perpendicular to the plane of incidence. So this is the plane of incidence. So this is my electric field. This is my electric field. So where will be my magnetic field? This is my electric field. So what will be my magnetic field? P cross E is equals to H. So H will be going downward. So which pen should I use? P cross H. This would be your HI. Now I am assuming, this is my assumption, that my reflected electric field is also coming towards me. So what is the assumption we are making? That incident, reflected and transmitted electric field all are in the same direction. So assumption, while deriving the formula in the previous case when we were studying normal incidence, while deriving the formula, what was the assumption made? That incident, reflected and transmitted electric field all are in the same direction. Now in case of perpendicular polarization, what is the assumption made? Incident, reflected and transmitted electric field all are in same direction. So this is the assumption. So always all the formula I derive using this assumption only, that my incident electric field is equals to reflected electric field is equals to transmitted electric field. This is obvious. This is obvious that incident and reflected will be in the same direction, but this is my assumption. Reflected, incident and transmitted will be in the same direction, but reflected can change its direction. Basically, reflected electric field can change its direction. So that is not changing. This is my assumption. Now I will derive the formula of gamma. If that gamma is becoming negative, if that gamma becomes negative, that means electric field is changing its direction. If this gamma becomes positive, that means electric field is not changing its direction. That we have already studied in normal incidence, right? This thing we have seen in a very in-depth manner, right? So now let's derive the formula, but before that let's show the direction of magnetic field as well, which we forgot to show. So here what will be the direction of magnetic field? Magnetic field will be P cross E. So P cross E. P cross E. So this will be my H. My H will be somewhere here. This you need to use your own hand. Like you cannot understand by my hands. You need to use your own hand. P cross E. So P cross E will be H. Now you can understand in this manner as well that E cross H should give me P. So that way also you can understand. And what about transmitted? Transmitted will have this direction only. Now tell me one thing, can you say that sir EHI is equals to EHT? Think about it. Can you say in this manner the direction of HI is equals to direction of HT? Is that correct? Yeah, sorry for the interruption. So what I was saying, is that correct? No, this is not correct. This is wrong. Both direction of HI and direction of HD is not same. Why is that so? Because of this angle. Here, this wave is coming at theta I angle, but transmitted at theta T angle. So this angle is different, no? If I want to find this particular component, let's just say I am finding this horizontal component. So what that component would be? What do you think? Look, if we solve some geometry, so this will be 90-degree angle. This would be 90-degree angle. This angle would be 90 minus theta t. This angle would be theta t, and this angle again would be 90 minus theta t. So this component would be ht cos 90 minus theta t. That would be sin theta t. So this component would be ht sin theta t. This is this component. I am just telling a very important concept. Okay, that why AHI and AHT is not equal. It seems like that they are equal, but because of this angle they are different. So what I am doing, this is my theta t, so this is my 90 minus theta t because this is 90-degree angle, so 90 minus theta t. This would be theta t only because this guy is perpendicular to this line. These are 90-degree angle. So this is 90 minus theta t, so this will be theta t, and now this is and this is also perpendicular. So if this was 90 minus theta t, this is theta t, so this would be 90 minus theta t again. So this is your 90 minus theta t. So ht cos 90 minus theta t would be ht sin theta t. Okay. Now what about this angle? What about this component? So if this is theta I, this would be also theta I. This would be 90 minus theta I. So this component would be hi into cos 90 minus theta I. So this component would have been hi sin theta I. So here theta I and here theta t, both are different thing, no? This component is also sine. This component is also sine, but this is theta I, this is theta t. So that will change the direction. Okay. One guy is this, and another guy is this. Both are clearly parallel. So I can say yes, the direction is same. But what if I tilt this guy? What if I tilt this guy? So direction is different now. If this guy was like this, that means both are having the same direction. Both are having the same direction. But if I tilt it, then direction will not be same. Orientation feels like same, that both are pointing here only, but direction has changed now. Okay, just a second, just a second of wait. Someone is knocking at the door. Yeah, so this point you must have understood that this HI and HT are not in the same direction. They have the same orientation, but the different angle. So because of that, the direction is different, right? So that is a very important point. These small points will help you a lot in MCQ's problem. Like in the MCQ, you will be able to solve very, very quickly if you know all these points. So that's why I am spending time here. This was your theta t. This is my this is my EI, this is my HI. EI, HI, ER, HR, ET, HT, and theta is equals to theta R. Yeah, more things we can write. What we can write, that this is my medium 1 and this is my medium 2. What is my plane of incidence here? XZ plane, right? Plane of incidence is XZ plane. And what do you think? What is your boundary plane here? What is my boundary plane? What do you think? Boundary plane is the XY plane, or you can say Z equals to 0. What is my boundary plane here? The wave is coming like this and reflected in this manner. Wave came like this and reflected in this manner. That means this has to be the boundary plane. And what is this boundary plane? This boundary plane is XY plane, right? So my boundary plane is XY plane. So these you do not need to remember actually, or you can say Z equals to 0. Just like any diagram you would make, there in the examination equations will be given. You need to draw the diagram. How will you make the diagram? All these practice we have seen. This is how we will make the diagram. And once we make the diagram, we will get to know what we need to find. It would be very easy in the problem. So if you have studied making the diagram, then all these things are cakewalk for you. So you don't need to remember anything. Only this assumption. If you want to remember, then you can remember. If you want to remember, okay. Again, I am telling, if you want to remember this assumption, then you can remember. Otherwise, you can ignore as well. Because gamma will take care. Gamma will take care of anything. Gamma is becoming negative, then you would get to know that direction is getting changed. Otherwise, direction is same if gamma is positive. So gamma will take care of every single thing. So that you do not need to care. Okay. Now, by looking at the diagram, you get to know that this is my boundary plane. That is xy is my boundary plane. This is z equals to 0. What is my plane of incidence? So whatever that plane I am making, that is my plane of incidence only. So plane of incidence is xz plane. Is that clear to you? Okay. And ahi is equals to not aht. So that we do not need to write, but this is just a point that I wanted to deliver. Now we will get some results. So how we will get the results? Like we need to apply the boundary condition and we need to find the reflection coefficient and the transmission coefficient. So I'm not gonna do the complete derivation. It is not useful as well. No one will ask you the derivation, but we at least need to write down the boundary condition. So how we will write down the boundary condition? So which is my boundary? This is my boundary, right? This is my boundary. If I make it more clear, this is my boundary. This is my boundary. Now, from the boundary, can you tell me what is the tangential component of electric field? What is the boundary condition? Boundary condition is that tangential component of electric field should be equal and tangential component of magnetic field should be equal. This is the boundary condition, right? Now, what is the tangential component of electric field? Across this boundary, what is the tangential component of electric field? All these are tangential only, no? EIO, ERO, ERO and ETO. EIO, what is EIO? This is EIO coming towards you. EIO is coming from the screen, coming out of the screen. And then ERO, that is also coming out of the screen. And ETO, that is also coming out of the screen. So EIO plus ERO. In medium 1, what you are having? In medium 1, you are having EIO plus ERO. Why I am putting plus? Why I am putting plus? Because both are in the same direction, EIO and ERO. Both are in the same direction. And I am applying the condition at z equals to 0. I will apply the condition just at the boundary. Basically, here I am applying the condition. Here I am applying the condition. So just at the boundary, I will apply the condition. Again, one call is coming. This is what happens when you record videos at home. Okay. So this is our first condition. I need to pick up the call. Then try writing down the magnetic condition. Try writing down the boundary condition for magnetic field on your own. Yeah. So we were studying boundary condition. So EIO plus ERO is equals to ETO. My dress got changed because it's the wedding season here, but that doesn't matter, right? So yeah, we have applied the magnetic boundary, we have applied the electric boundary condition. Now we need to apply magnetic boundary condition. So this is our equation 1. So now you tell me what is the tangential component of magnetic field across the boundary? Tangential component I am asking. Basically this magnetic field is having two components, this component and this component. Which one is tangential? This is my boundary. So this component is tangential, right? Z equals to 0. This is my boundary. So this component has to be tangential. There is no doubt about that. Okay. So now this component I need to find. How will I find this component? Look. What about this? What is this angle? Theta r only, right? If this is theta r, this is also theta r. So better write it theta I, because theta r is equals to theta I only. So let's write it theta I. Now if this is theta I, then what this angle will be? 90 minus theta I. Why so? Because this angle and this angle, this is completely 90 degree. So this angle would be 90 minus theta I. Now what about this angle? This angle would have been theta I, right? Because this complete angle is 90 degree. So that angle would have been theta I. So what is the tangential component of HR? That we can write down. This component would have been HR cos theta I, right? Now what about this? What about this? Which one will be the tangential component? This will be the tangential one, right? Because you can see the plane. This is my plane, so this will be the tangential component. Now let's try to find out. This is theta I. So what this would have been? 90 minus theta I, right? Then what would this would have been? Theta I only. So what this component would be? HI cos theta I, right? What about this guy? So this component would have been the tangential component, right? So how would I find that? If this is theta t, this would be 90 minus theta t. Say yes or no, right? Because if you just extend this one, if you just extend it, this would be 90 degree. So this would have been 90 minus theta t. And if that is 90 minus theta t, so this rest would have been theta t only. So this is your HT cos theta t. Now I need to apply the magnetic boundary condition. So what I can see? HI cos theta I, better I should write HRO, HIO and HTO. because I will just write down the magnitude. So HIO cos theta I minus HRO cos theta I. Why minus? You can see why minus, because HRO is in the opposite direction, is equals to HTO cos theta T. So HIO cos theta I minus HRO cos theta I is equals to HTO cos theta T. Now can I write down this as EIO divided by eta 1? Certainly I can write down, right? And cos theta I will take common. Then can I write it down in this manner? ERO divided by eta 1 cos theta I. And can I write it down this as ETO divided by eta 2 cos theta T. So let's not call this as equation 2, let's call this as equation 2. Now if you solve equation 1 and 2, you can solve it on your own, you can solve these equations, okay. Solving equation 1 and 2, you will get the value of reflection coefficient. What is the reflection coefficient? Reflection coefficient is ERO divided by EIO. What formula you will be getting? You will be getting this formula. Neta 2 cos theta I minus neta 1 cos theta T divided by neta 2 cos theta I plus neta 1 cos theta T. This is the reflection coefficient, but we are finding it for electric field only, okay. Reflection coefficient we have found, but for electric field. So this you have to remember. In the end, certainly I will tell you how you will keep it in mind. Initially it was neta 2 minus neta 1 divided by neta 2 plus neta 1. Now it has become neta 2 cos theta I minus neta 1 cos theta T, neta 2 cos theta I plus neta 1 cos theta T. Now how will you remember that, sir, whether here theta I would come or theta T would come? How will you remember whether here theta I would come or theta T would come? So what do you mean by perpendicular? This is how you show perpendicular, right? Perpendicular means two lines are cutting. One line is cutting the other one. Perpendicular means one line is cutting the other one. So how will you write down the formula? That this is my medium 1, this is my medium 2. So neta of this medium, angle of this guy. Neta of other medium, angle of the first guy. Minus neta of this medium, angle of the other guy. Because two lines are cutting. Two lines are cutting. But in case of parallel, two lines never cut. That means neta 2 cos theta T minus neta 1 cos theta I. That means neta of this medium, angle of this medium as well. What do I mean by angle of this medium? Basically here the angle is theta T, no? So neta of this medium, angle of this medium. So neta 2 cos theta I. So this is the way to remember. I will again tell it, but eventually you have to remember the formula. There is no shortcut, there is nothing. If you want to solve the problems, you have to remember the formula. There is no doubt about that. So this is your gamma perpendicular. Always mark that we have derived the formula for electric field. ERO divided by EIO we have done, not HRO divided by HIO, okay. So the way we solved problem in normal incidence, first we will solve for electric field, then from there we will go to the magnetic field. Is that clear to you? Yes. And then what about the transmission coefficient? So 1 plus gamma perpendicular E is equals to 2 perpendicular E. So this is your transmission coefficient. It is same as your normal incidence, right? So these two formula anyway we have to keep in mind. So first thing is you should know how to apply the boundary condition. This you should know how to apply the boundary condition. And second, you need to remember the formula. So all the 5 lines that I have written, that you should be able to write, okay. There you cannot derive it and then find out this value. So eventually you have to remember. And trick also I have told, perpendicular both will cut each other. So neta of this and angle of this. So neta 2 cos theta I. In that manner you can remember, okay. Now there is something called Brewster angle. What do you mean by Brewster angle? So add the angle, add the incidence angle when there is no reflection. The angle, this angle, the angle of theta I such that there is no reflection. All part is transmitted. So that is known as your Brewster angle. Incident angle at which there is no reflection. So at theta equals to Brewster angle, what will happen? Your gamma perpendicular will be 0. What is your gamma perpendicular? Neta 2 cos theta I minus neta 1 cos theta T is equals to 0. Basically this guy will go to 0. There should be no reflection. All parts should be transmitted. Is that clear to you? So from here what you are going to get? Neta 2, this is neta, okay, so I should write neta in this manner. Neta 2 cos theta I is equals to neta 1 cos theta t. And by Snell's law, what do you know? There is Snell's law, right? Snell's law. If you remember Snell's law, what was your Snell's law? Snell's law was saying that beta 2 sin theta t is equals to beta 1 sin theta I, right? If you remember clearly, beta 2 sin theta t is equals to beta 1 sin theta I, right? So two equations are there. This is equation 1, this is equation 2. And if you solve these equations, what you are going to get? You are going to get the formula of theta b perpendicular. Basically, this is your Brewster angle. This is known as Brewster angle. Okay, so I will write down the formula. Here I am writing, this is my Brewster angle. So Brewster angle is nothing but the incident angle where there is no reflection. So if you solve these two equations, you will get the formula, but eventually you have to remember the formula. So what is that formula? So sine square theta b perpendicular is equals to 1 minus epsilon 2 by epsilon 1 into mu 1 by mu 2 divided by 1 minus mu 1 by mu 2 whole square. Okay, so this is the result you will be getting. A very important result, I hope you will keep in mind. How do I remember it? That I will tell later on when we write down the conclusion. So till now this formula we have studied, these two formula we have studied. We will write down conclusion for everyone, right? The same kind of derivation that we have seen for perpendicular polarization, now we will see the same derivation for parallel polarization. Then we will write down the summary. After that we will solve the problem. So here this derivation and all, it is not important for this particular chapter. Okay, where derivation was important in Maxwell's equation, when we were deriving the EM wave equation, there the derivation was important. That's why I spent time there. But here this is mathematics. I'm not gonna spend time here, right? So the final results are important here. Okay, and in perpendicular polarization, what was the assumption? Do you remember what was the assumption? That all the electric field are in the same direction, incident, reflected and transmitted. If this is changed, if this direction is changed, then formula will change. Basically here negative sign will come, but you will not remember this thing. You will just remember that my gamma will take care. If gamma is becoming negative, that means certainly electric field is changing its direction, otherwise electric field is not changing its direction. So that was the assumption. Then we derived this formula. This trick also I have told, eventually you have to remember, and this is the formula of Brewster angle, that also I have told. Okay, so that also you need to remember. For non-magnetic material, from here if I write for non-magnetic material, for non-magnetic material, what will happen? Mu 1 will be equals to mu 2 will be equals to mu naught, right? Because mu r is 1. For non-magnetic material, mu r is 1. So what will happen here? Sine square theta b perpendicular. What will happen here? This will be 1 only. 1 minus 1 is 0. So this will be infinity. That means Brewster angle is not defined for non-magnetic material. Not defined. So that's why in the examination you will never see that they will ask Brewster angle for perpendicular polarization. They will ask Brewster angle for parallel polarization. Brewster angle is a very important concept, but it will be asked for parallel polarization only. It will not be asked for this. Okay, but still we need to remember the formula. Who knows what can be asked? So this is the formula you need to remember. How will you keep in mind that, sir, epsilon 2 by epsilon 1, mu 1 by mu 2, how you will keep in mind? Then certainly I will tell. Okay, once we derive the formula for parallel polarization, so I will tell you how to remember all these formulas. Okay, because if there is something to mug up, then certainly I tell you any trick so that you can keep in mind, right? Let's go to the parallel polarization. So parallel polarization diagram you can make on your own. So this is my, or shall I make it for you? But this we have already studied, so you can make it on your own, but since I am an educator, so I will make it for you. Okay, so what is the scene? My electric field has to be in the plane of incidence. This is my plane of incidence. What is my boundary plane? You should be able to tell. What do you think? What is my boundary plane? The wave is striking like this, so this has to be my boundary plane. And what is this plane? That is z equals to 0. So boundary plane is Z equals to 0. So the wave is coming like this. Now what about the electric field? Electric field has to be in the plane of incidence. So electric field can be like this or it can be like this. So I am assuming it is like this. Okay, I am assuming it is like this. Then where will be my H? E cross H. So H has to be coming towards me. EIS, HIS. Now here, now this is the way it is going. Now electric field could be in two direction. Here as well, electric field could be in two direction, either here or here, because it has to be perpendicular and it has to be in the plane of incidence as well. So it can be here or here. I am assuming it is here. Okay, I am assuming it is here. This is my reflected. So what will be the direction of my magnetic field? That would be inside. And in this case, orientation will remain same only. So this will be your electric field. This is your electric field and magnetic field will be going inside. HTS and this is ETS. Is that clear to you? So can you tell me what is the assumption we are making for deriving the formula? Can I say that EIS is equals to ERS? Is this the assumption? Certainly you can see here EIS is not equals to ERS because EIS is pointing here, ERS is pointing there. So how you can say EIS is equals to ERS? But one assumption I can tell, what is that? That incident magnetic field and reflected magnetic field are having the opposite direction. What assumption I am making? In this, what was the assumption? That electric field are in the same direction. This was the assumption. We were not commenting on magnetic field. We cannot even comment on magnetic field because this magnetic field is here, this magnetic field is here. Certainly the direction are not same, but we cannot even say the direction are opposite. No, opposite of this direction would be this direction, but reflected magnetic field is in this direction. So we cannot even say that a direction are opposite. We can just say that direction are different. Same goes in this case, but in this case it goes for electric field. We cannot say this is your incident, this is your reflected. Now we cannot say they are opposite or they are same. We cannot use two words. We cannot say that incident and reflected electric field are opposite. No, we cannot say that. Why is that so? Because opposite of this would be this. But reflected electric field is in this direction. So they are different, but they are not opposite. That's for sure. These directions are different, but certainly they are not opposite. Is that clear to you? Okay. So that we cannot comment. But what we can comment? We can comment that my incident magnetic field and my reflected magnetic field are opposite in direction. What I can comment is that my incident magnetic field is equals to the reflected magnetic field, but direction is opposite. Okay, only I am talking about the direction. Magnitude will certainly depend on other factors, but direction would be opposite. Is that clear to you or not? Right? So this is the assumption while deriving the formula. You do not need to remember it, okay? For solving the problems, this will not be used. For solving the problems, we will make the diagram on our own, and certainly we will be getting to know that which direction our electric field will go, which direction our magnetic field will go. So you do not need to remember it. But always what we have assumed, always in all the derivation, once we started with the normal incidence. So in normal incidence, what did we assume? That electric field are in same direction. Yes. In case of perpendicular polarization, what did we assume? That electric field are in same direction. In case of parallel polarization, what we are assuming? We cannot comment on electric field. That's why we are saying that magnetic field are in opposite direction. We are not saying they are in the same direction. Same direction goes for electric field. Opposite direction goes for magnetic field. So that is the easier way to remember it. Is that clear to you? Okay. Yeah. So that is the assumption we are making for deriving the formula. So now let's derive the formulas. Okay. So let's apply the boundary condition. So what all boundary condition we know that tangential component of electric field should be equal and tangential component of magnetic field should be equal. So let's first make the tangential component of magnetic field equal because they are very easy. So what I can say, HIS is coming towards me, HTS is also coming towards me, but HRS is going inside. So what I can write, HIO minus HRS is equals to HTO. So EIO divided by eta 1 minus ERO divided, why I am writing HRS, would be HRO is equals to ETO divided by eta 2. Is that clear to you? So this is the equation 1 I am giving. What could be the other equation? Other equation for electric field now. So what will be the tangential component? This will be the tangential component. So let's write down all the tangential component. this will be the tangential component here. Here this will be the tangential component, and here this will be the tangential component. So these values I need to write. So let's see the angles. Now you should be habitual of writing down the angles. This would be your, this is equals to theta I only. So this would also be theta I. This is 90 minus theta I, so this would be theta I only, right? This is your theta I, this would be 90 minus theta I, this would be your theta I only. What about this guy? This is theta T, and if I increase this would be 90 minus theta T. This angle 90 minus theta T, this is 90 degree only, so this has to be theta T only. So this angle will also be theta T. What I am saying is that this is my 90 minus theta T, okay, and this is 90 degree only, that I already know. So 90 plus 90 minus theta T, and then total angle, this total angle should be 180 degree, right? What I am saying, on this line the total angle should be 180 degree. So 90 I am having, 90 minus theta T I am having, so other one left is theta T only. So this is my theta T only. Is that clear to you? So what all are the answers I am getting? So let's remove it off, let's remove it off. So angle you should be habitual of writing, because that is simple geometry, nothing else. So here you will get, this is your EIO cos theta I. Here you will get ERO cos theta I, and here what you will get, ERS cos theta T, and all are in same direction. EIO, ERO and ERS, all are in same direction. Sorry, this is ETS, really sorry, ETO, I should write ETO. So what I am gonna do, EIO cos theta I plus ERO cos theta I is equals to ETO cos theta T. You can see it clearly, right? All are in the same direction. So once I solve these two equations, what I'm gonna get? I'm gonna get the reflection coefficient, but reflection coefficient for parallel polarization. Reflection coefficient for parallel polarization. And what do you mean by reflection coefficient? That is ERO divided by EIU. Now this is parallel. Parallel means this is my medium 1, this is my medium 2. So neta of this medium and theta of this medium. Okay. So what formula I will write? This is the way to remember, nothing else. Neta 2 cos theta T minus neta 1 cos theta I divided by neta 2 cos theta T plus neta 1 cos theta I. Mark that we are writing all these formulas for electric field. Okay. So only these formula you need to remember for electric field only. We do not remember any formula for magnetic field, right? Now 1 plus gamma E is equals to tau parallel E. No, this is not completely correct. What will happen is that here one more thing will come. What is that? Cos theta T divided by cos theta I. Now this is the complete formula. So these two formula you need to remember. How will you remember it? In a longer run you would be able to remember, there is no doubt about that. Okay, but one was perpendicular, one was parallel. So for a short term, how would you remember it? One was perpendicular, one was parallel. If I ask you write down E from here, from this geometry make E, how will you make E? Yes sir, this is easy to make E. I can make E from here. But if I ask you make E from this geometry, how will you make E? Like it doesn't look like a good E. Which one is looking at a battery? This is looking at a battery. So for perpendicular polarization, E is happy. For perpendicular polarization, E is happy. Is that clear to you? If E is happy, then certainly there is very simple formula. But for parallel polarization, you are not getting correct E. You are not getting a good E. So E is not happy. That's why he is making this kind of formula. Now here you will have the doubts that sir, whether cos theta E should come upward or cos theta T should come upward. So what is tau? Tau is transmission coefficient. What is tau? Tau is transmission coefficient. Transmission coefficient. Right? And transmission is related with theta T, not theta I. Tau is a transmission coefficient. Tau is transmission coefficient, and transmission is related with theta t, because this is the transmitted wave, no? So that is related with theta t. So upward direction theta t would come. Is that easy to remember or not? Tell me. Look, 1 plus gamma perpendicular is equals to tau perpendicular, and 1 plus gamma parallel equals to tau perpendicular, and something here will come. That in a longer run you will remember. But in a longer run you might be confused that, sir, whether I should put theta I here or theta t here. So for that, what you will say? Okay, sir, tau is the transmission coefficient. Tau is the transmission coefficient. That means it is associated with transmission. It is associated with transmission. That means transmission angle is theta t only. So that theta t would come. So cos theta t divided by cos theta I. But once we will solve the problem, these formula will fit in your mind. Okay, no doubt about that. Also, you can remember that perpendicular is happy with E, but parallel is not happy with E. So for that, something change will come. Is that clear to you? All good, all clear. Okay, so these are the formulas we have developed. Let's see the Brewster angle. Very important for your this case. Very important for parallel polarization. So Brewster angle means you already know what do we mean by Brewster angle. At that angle, at that incident angle where there is no reflection, so that is known as Brewster angle. So what we will get to know, this is my Brewster angle. Okay, so neta 2, here I will write neta 2 cos theta t would be equals to neta 1 cos theta I, right? Because if this is 0, then both will be equal. Neta 2 cos theta t is equals to neta 1 cos theta I, and beta 2 sin theta t is equals to beta 1 sin theta I. These are the two equations. If you solve both of the equations, then what you are going to get? I am not looking at the formula, I am just looking at this guy. Okay, don't think I need to see the formula before writing it. I remember all the formulas. Yeah, so if you solve these two equations, what you are going to get? So solving 1 and 2, at least this formula I will remember, right? 27 रैंक था मेरा, तो इतना तो मेरे को याद होगा. Okay, so 1 minus epsilon 2 by epsilon 1. कर दी गड़बड़ भाई, कर दी गड़बड़, हो गया. mu 2 by mu 1 into epsilon y by 1 by epsilon 2, 1 minus epsilon 1 by epsilon 2 whole square. I said I remember the formula, but here I did the error initially. How do I remember it? Look, this is your parallel line. Now from parallel line, if I ask you to make epsilon, it will be tough. But if I ask you to make mu, you can make it very easily. From parallel line, if I ask you to make epsilon, it will be very tough. But if I ask you to make mu, you can make it very easily. So your formula will start from mu. 1 minus mu 2 by mu 1. If here 2 by 1 is coming, so certainly here 1 by 2 would come. Then 1 by whatever that you have written here, that will come downward. Epsilon minus epsilon. This is how I remember. I remember the formula only for parallel polarization. If I need to write down for perpendicular polarization, what I will think? For parallel polarization, mu is very easy. So for perpendicular polarization, epsilon will be easy. So for perpendicular polarization, first epsilon will come. 1 minus epsilon 2 by epsilon 1 into mu 1 by mu 2, and whatever that you have written, that comes downward. Is that clear to you? This is how I remember. This is how you can also remember. 1 minus parallel, mu is easy to make. So 1 minus mu 2 by mu 1 into epsilon 1 by epsilon 2 divided by 1 minus epsilon 1 by epsilon 2 whole square, and that's the answer. Is that clear to you? Okay. Here there is no issue of that non-magnetic material, right? Because if a material is non-magnetic, then what will happen? For non-magnetic material, what will happen is that mu 2 will be equals to mu 1 will be equals to mu naught. So this guy would be 1 only. So which formula you will get? You can see it. Divided by 1 minus epsilon 1 by epsilon 2 whole square. Can I apply a square minus b square here? Yes, I can apply. So what I will get? A minus b into a plus b. A minus b will be same as this. So that will be cancelled. So what you are getting? 1 upon 1 plus epsilon 1 by epsilon 2. So what you are getting? Epsilon 2 divided by epsilon 1 plus epsilon 2. That is equals to sine square beta parallel. Okay. If I need to write down tan square beta parallel, if I need to write down tan square beta parallel. So what that would be? That would be epsilon 2 by epsilon 1. Tan square beta parallel would be epsilon 2 by epsilon 1. And from here, if I need to write down tan square beta parallel, tan square theta b parallel, sorry, not beta parallel, theta b parallel, I should say. So if I need to write down theta b parallel, then what will be the answer? Tan inverse under root epsilon 2 by epsilon 1. And epsilon 2 by epsilon 1 can be written as epsilon r2 divided by epsilon r1, because epsilon is equals to epsilon r epsilon naught. This is epsilon 1, this is epsilon 2. So if you just divide them, epsilon naught get cancelled, you will get epsilon r2 divided by epsilon r1. Is that clear to you? So that this derivation you are not going to do in the examination. I am just telling how the formula came. So directly we will write down the formula. What is the formula now? That for non-magnetic material, your theta b parallel would be equals to tan inverse under root epsilon r2 divided by epsilon r1. Another formula. So these formula are there. I know there are a lot of formula, but you need to keep the things in mind. Otherwise, you cannot derive all the things in the examination. Okay. And if I am asking you to remember anything, then certainly I am telling you the tricks as well, that how you can keep these things in mind. So parallel mu. So first mu will come. So 1 minus mu 2 by mu 1. It's not that you will remember only this formula. This formula also you need to remember. I am not saying that you remember this formula. Better remember this formula only. Because from here to here you can go anyway. But from here to here you cannot go, right? If you remember this one, then certainly you will be able to get this answer. So I highly recommend to remember this formula for sure. And that is equal to sine square theta b parallel. Sine square theta b parallel. So sine square theta b parallel is equal to 1 minus mu. Parallel is mu. So 1 minus mu 2 by mu 1 into epsilon 1 by epsilon 2 divided by 1 minus epsilon 1 by epsilon 2 whole square. That's it. There you go. Okay. So now we will write down all the formula, all the summary we will write down, and we will see what all things we need to remember. As of now, if we revise whatever that we have studied, so first we saw the meaning of oblique incidence, then we saw about the plane of incidence, then we saw there are two kind of polarization. Electric field has to be parallel to the plane of incidence, then parallel polarization, also it is known as p polarization, and for perpendicular polarization, electric field is perpendicular to the plane of incidence. Then we saw how to make the diagram. This is how you will make the diagram. So we built a good habit of making the diagrams, because that will be highly used in our problem solving. Then how to determine the boundary plane, how to determine the plane of incidence, that we have seen. Then we started studying about the formulas. First we saw the basic wave optics. So those wave optic concept we are going to use. So this is something which we need to remember. These two formulas are something that we need to remember, that our angle of incidence is equals to angle of reflection. But for transmission we apply the Snell's law. The Snell's law is beta 1 sin theta is equals to beta 2 sin theta t. Okay. Then if mu1 is equals to mu2, mu1 is equals to mu2 is equals to mu naught. If mu1 is equals to mu2 is equals to mu naught, then this formula would come. Okay. Then we saw the derivation for perpendicular polarization, and for this was the boundary condition. We got the formula. How do we remember the formula? Perpendicular, that means two lines will cut each other. So neta of this guy and theta of this guy. So neta 2 cos theta I minus neta 1 cos theta t. Always mark that we are deriving these formulas only for electric field. And from this perpendicular, I can write down E. So that means perpendicular polarization is happy with E. And if it is happy with E, that means 1 plus gamma is equals to tau. That's it. That's the simple formula. So that is the transmission coefficient formula we are getting. And the same formula, then we derived the formula for Brewster angle, which is not that important. So that's why I'm not going to put star mark. But you can keep in mind. How will you keep in mind? You will keep the formula in mind for parallel polarization. So for parallel polarization, mu will come first. So here epsilon will come first. 1 minus epsilon 2 by epsilon 1 into mu 1 by mu 2 divided by 1 minus mu 1 by mu 2 whole square. And if non-magnetic material is there, then it is not even defined. For parallel polarization, we saw the conditions. That what is our assumption here? Assumption is that magnetic field is changing its direction. That is the assumption. We are not making any assumption for electric field. Is that clear to you? Then we saw the formulas for parallel. That means parallel, two lines are not cutting each other. So neta of this guy and angle of this guy. So neta 2 cos theta t minus neta 1 cos theta I divided by neta 2 cos theta t divided by plus neta 1 cos theta I. So here there is no change basically. Whatever that you write upward, the same thing will come downward. Just here it is minus, here it would be plus. Is that clear to you? Whatever you write upward, that will come downward. Just minus and plus difference is there. And here from parallel you cannot make E very easily. So E is not happy. That's why something different will come. So 1 plus gamma is equals to tau. But along with that, what is the scene? Some cos angle would come. Now how will you remember that which cos angle will come? So for that, what we have studied, that tau is related to the transmission. So first transmission coefficient would come. Is that clear to you? Yes. Okay, then we saw the Brewster angle. For Brewster angle, first mu will come, so 1 minus mu 2 by mu 1 into epsilon 2 by epsilon 1 divided by 1 minus epsilon 2 by epsilon 1 by epsilon 2 whole square. A very important point to note. What is the very important point? The most important point is this sine square theta b parallel, because people will be forgetting this sine square theta b parallel. They will just remember 1 minus mu 2 by mu 1. Now, what it was equal to? It was equal to tan square beta parallel or sine square beta parallel. So, it was equal to sine square beta parallel, or I should say sine square theta b parallel. So, always remember it was equal to sine square theta b parallel. Is that clear to you? Okay. Now, let's write down the summary. So, this is the summary, that these two were the formula that we studied initially. Then these we studied for electric field. And how do we remember it? Cross, right? We remember it by cross. That perpendicular are crossing each other. So, neta 2 cos theta I. This is how we remember. We have just seen the summary as well, right? So, all these are for electric field, and these were the Brewster angle, right? How do you remember the Brewster angle? For parallel, parallel means mu. So, first 1 minus mu 2 by mu 1 into epsilon 1 by epsilon 2, and whatever that you write here, that will come downward. So, this is how you remember. So, if you write down the formula for theta b parallel, then you can certainly write down the formula for theta b perpendicular as well. Say yes or no? Yes? Okay. Now, these were the formula for electric field, but what if they ask the formula for magnetic field? So, how will you write down the formula for magnetic field? So, that we will write down, but first you see these formula for non-magnetic material. This is the theta b parallel. What is that? Under root epsilon r2 divided by epsilon r1, and theoretically, if epsilon r2 is equal to epsilon r1, then theta b perpendicular will also be this. What do I mean to say is that if epsilon r2 is equal to epsilon r1, if this guy is equal, then theta b perpendicular can also be written like this. But for two medium, epsilon will never be same. If I am saying that my wave is propagating from here to here, so if this is medium 1 and this is medium 2, certainly epsilon has to be different. Mu can be same. The material, both material can be non-magnetic, but epsilon will never be same for two medium. So that is that's why I have written theoretically, right? And there are a lot of things for perpendicular polarization. If non-magnetic material are there, then your Brewster angle is not even defined. If a non-magnetic material are there, then Brewster angle is not defined for perpendicular polarization. So that's why I say that only this will be asked in the examination. This will not be asked. Because if you say epsilon are equal, that is also not possible. But that's why I have written theoretically. If theoretically they are framing any question that epsilon they have made equal, and still they are asking you the Brewster angle for perpendicular polarization, then you can apply these formulas. So always I am asking you to remember this formula only because I know question will be framed on this. So always I ask to remember the perpendicular polarization, parallel Brewster angle formula. Brewster angle for parallel polarization. That formula I ask to remember, and that you can remember from this parallel line. So mu should come first. Okay. So that's why I have written theoretically. And one more thing was there, that for non-magnetic materials, Brewster angle is not defined. Right. Now we will write down some formula for reflection coefficient and transmission coefficient, but for magnetic field. We have write down those formula for electric field, right? We have write down the formula of reflection coefficient in case of perpendicular polarization for electric field. We have write down the transmission coefficient in case of perpendicular polarization for electric field. Same goes for parallel polarization as well. So all the formulas that we remember only for electric field. In the question, we will be always solving with respect to electric field, and then we will convert it into magnetic field. So for numerical purpose, these formula will be used, this and this, for numerical purpose. But what if in the options they frame these formula and then they ask you which of the formula is correct and which of them is incorrect? So these kind of questions can also come. So that's why we are writing down this formula. But you do not need to mug it up. Okay, just for numerical purpose these will be used, but there is a very slight chance that in the options they can frame some questions like this, and then they can ask you that which of them is correct. Okay, so in case of normal incidence, what did you study? That gamma is equals to minus gamma h. Yes, right? Same goes for perpendicular polarization as well, and same goes for parallel polarization as well. That gamma perpendicular E is equals to minus gamma perpendicular h, and gamma parallel E is equals to minus gamma parallel H. Is that clear to you? Whatever that you studied in normal incidence, the same goes here as well. Now, what was your gamma 1 plus gamma parallel E? What was your 1 plus gamma parallel E? That was tau parallel E. But since parallel will not make E beautiful, that's why something else will come. So what that would come? Cos theta T divided by cos theta I. So in case of parallel polarization, when you write down the formula of electric field, something is coming. Now in case of parallel polarization, when I will write down the formula for magnetic field, then nothing will come. Just opposite you need to take care. And what do you think what will happen here? 1 plus gamma perpendicular E is equals to tau perpendicular E. Nothing was coming. Why nothing was coming? Because this was perpendicular. So E can be made very easily. So E is happy. So nothing is coming. So now if you write down for magnetic field, then something will come. And what will come? That you already know. What will come? Cos theta T divided by cos theta I. Say yes or no. Will you be able to remember this point? Now let me write down the summary of these formula. Basically, these I need to remember for my examination, for my numerical purpose. But this sometimes can be framed in the options. So I should have the ability that at least by looking at the option, I should be able to tell whether this formula is correct or not. This formula we will not be using for numerical purpose. Okay? There is surety about that this formula we will never be used for numerical purpose. But if they have framed in the options, then we cannot do anything. Is that clear to you? So let's write down the summary again, that what all we have studied. So first we have studied for normal incidence. For normal incidence, what was the scene? First one was that gamma E is equals to minus gamma H, right? Second one was 1 plus gamma E is equals to tau E. 1 plus gamma E is equals to tau E. And third one was 1 plus gamma H is equals to tau H. There is no doubt about these three formula, if you remember clearly, right? Now, in case of oblique, so in case of oblique, there are two kind of phenomena. One is the parallel polarization. So that is equals to H. And in case of there is perpendicular polarization as well. So this is same only. This is same as normal incidence. There is nothing different. That gamma E is equals to minus gamma H. Whether it is parallel polarization, whether it is normal incidence, or whether it is perpendicular polarization, all are same. Gamma is equals to minus gamma H. But this formula 1 plus gamma parallel E is equals to tau parallel E. But since parallel is not happy with electric field, so that's why what we need to do, we need to add up something. That would be cos theta T divided by cos theta I. Is that clear to you? Now what about this? Here if I write down for this, I am writing for electric field. This I have written down for electric field, and yeah, here if I write down this thing, what will be the answer? Tau perpendicular H. Directly it will come. Why directly? Because from perpendicular you can make E easily. So this is how we can remember it. So these formula I asked you to remember. Now the third one is, if you write it for magnetic field, so how will you write down? That in case of electric field something was coming, so in case of magnetic field nothing will come. This is how you need to remember. And now here, in case of electric field nothing is coming, so in case of magnetic field something will come. That's it. Will you be able to remember in this manner? So for examination purpose, for numerical purpose, you do not need to remember it. But in sometimes in the options, if these things are written, then you will be able to recognize that at least I have studied this. In the options, if you find something like this, then at least you will feel like that, at least I have studied this, so now I can attempt it. They will just frame a question that which of the following formula are correct. So these formula you need to check. That's it. Okay. A very rare chance, but who knows, wherever it might be used. So that's why we are writing down. But for examination purpose, you just remember this, and certainly this one. That's it. For examination purpose, you need to remember this, and this. For numerical purpose, sorry, not for examination purpose, for numerical purpose, you need to remember these formula. But in the options, if these kind of questions are coming, then you can mark it correctly. Trick I have already told, and this trick also you should remember, that tau is related with transmission. So that's why first transmission angle would come. Okay. Now let's write down about time average Poynting vector. So for both of the polarization, the formula are same. For both of the polarization, time average Poynting vector formula are same only. So what all are those formula? So in case of normal incidence, what we have studied, the reflected power was gamma E square times of pi. Basically, if this was my incident EM wave which was carrying the power pi. So reflected EM wave would be having gamma E square pi power, right? Same goes here as well. In case of perpendicular or parallel, basically if this is the incident wave, then reflected wave will have gamma square times power of incident wave. If I say my gamma parallel E is 1 by 2. So if incident power was pi, then reflected power would be pi by 4. Is that clear? It could be same. It would be same for perpendicular polarization as well. Like let's just say my gamma perpendicular for electric field is 1 by 3. So my reflected power will have pi by 9 power. Is that clear? Okay. But in the transmitted power there is something different. What is that? 1 minus gamma E square. Now here something would come. So cos some angle would come divided by cos some angle would come into pi. Gamma is associated with reflection, right? Gamma is associated with reflection. And for reflection, you need to take theta I angle in action. So first theta I would come, then theta t would come. Gamma, you will see gamma here. Gamma is associated with reflection, right? And with reflection, the angle of incidence is theta I. For transmission, we were writing theta t. But for gamma, we will write theta I. Is that clear to you? So this is the way to remember. Now in this case, for normal incidence, Pi was equals to P reflected plus P transmitted. Basically, whatever the power is coming, some will be reflected back and some will be transmitted. This would be Pi, this would be your PR, and this would be PT. Transmitted. T stands for transmitted. So this was the case for normal incidence, right? But this is not the case in your oblique incidence. You can check here as well. Like if you add both of them, what you are gonna get? Pi only. But if you add these two, then you are not gonna get Pi. So what I am writing, my Pi is not equals to P reflected plus P transmitted. Okay. So there is some power loss. Some power is lost. So this we will analyze with respect to numerical as well. So all these formulas are clear. You should not have pressure in your mind. What I am telling, basically, these will be used for numerical purpose. From this formula, direct question can be asked. These will be used for your numerical purpose. From this formula, direct question can be asked. Then these are derived from the previous cases only. There is very rare chance that they will ask a question for Brewster angle for perpendicular polarization. They will, if they are asking Brewster angle, then 99% chances are there that they will ask for parallel polarization only. So these formula I have told that gamma perpendicular you need to write. Perpendicular means two are cutting. So neta of this, theta of this. So neta 2 cos theta I minus neta 1 cos theta t divided by just minus sign, that would be plus. And if you need to write down parallel means two lines are parallel, so they are not cutting. So neta and theta of this guy only. Neta 2 cos theta t minus neta 1 cos theta I, and then just addition in the downward. Then perpendicular 1 plus gamma perpendicular is equals to tau perpendicular. So something will come or not, that will be decided by this perpendicular guy. So it will be made as E. Yes, it is directly being made as E. So electric field is happy. So if electric field is happy, then directly this formula will be applicable. But from perpendicular, E cannot be made very easily. So for that, electric field will develop some different thing. And what is that? Cos theta t divided by cos theta I. And how would you remember that theta t would come upward? That you will remember it from tau. Tau is related with transmission coefficient. So transmission, the angle is theta t. This is how you will remember. And for Brewster angle as well, I have told you the trick how you remember the formula. So Brewster angle perpendicular mu can be made very easily. So 1 minus mu 2 by mu 1 into epsilon 1 by epsilon 2 divided by 1 minus whatever that has been written, that will come downward. So this is how we remember the formula. So this is the trick, that's why you will be able to solve in the examination, because there are a lot of formula and people feel like that's how to remember. So every single trick I have told you, and I don't think that is too much tough for you to remember, right? then these are derived from the previous expression only, so you can anyway derive it in the examination as well. For magnetic field, now we are writing down the transmission coefficient and reflection coefficient for magnetic field. So gamma E is equals to minus gamma S, that will always be applicable. What was happening in perpendicular in case of electric field, that will happen in parallel in case of magnetic field. So that will be just interchange. So here in case of electric field there was nothing in case of perpendicular, but in case of magnetic field there is cos theta t divided by cos theta I in case of perpendicular, and here in case of parallel there is nothing. So that is the way to remember. These you do not need to remember for your numerical purpose, but in the examination if they frame an option that which of the formula is correct, then it will be helpful for you at that particular time. Is that clear to you? Yes. Then these are the again summary we wrote. We are writing down the summary in summary. Okay, so again the summary we have wrote that these are the formulas. So just I am afraid that sometimes what if they ask in the options that which of the formula are correct. So at that time you might be facing some problem that, sir, now how will I mark the option, because I do not even remember the formula for magnetic field. So for formula for magnetic field you do not need to remember for numerical purpose, but for option purpose, since it is gate examination, for option purpose you need to remember it. And then simple part is for time average pointing vector, that only difference is that transmitted power will develop something else. And how would you remember? This is your reflection coefficient. So reflection coefficient, that means it is associated with theta I only. So first theta I will come, then downward theta t would come. Okay, and these are the formula for normal incidence only. Just for revision purpose I have written it again. So that's it. This is about the complete conclusion, you would say, of this complete lecture. Okay, so only you might not be able to remember this derivation, no one cares. But whatever the summary that I have written, if you just remember those part only, then you will be able to solve all the problem. So now we are going to solve the problem. So just 10 minutes break I will take. You can also take a break, and then we will start solving the problem. So 5 problems we are going to solve. This is first one is very easy. Then this is also very easy. Now this is a good problem. So this will take some time. I guess it will take 30 minutes. I guess 20 to 30 minutes it will take. And now this is a gate problem which is very easy only. Okay, then yeah. So we will start solving it. So let me take a break. You can also take a break. Then we will start.